Chapter 1 Physical Quantities, Units and Symbols. In this chapter, I am going to discuss on what are physical quantities, what are base quantities, their units and symbols, what are derived quantities, and how to convert one unit from another. 1.1 What are physical quantities? A physical quantity is a representation of a physical property of an object. Physical properties are used to describe an object and its surroundings. Mass, length, color, etc. are the physical quantities which are used to describe the appearance of an object. Time, speed, acceleration, etc. are used to describe the motion of an object. Charge, field potential, field strength, etc. are used to describe the electric field produced by an object. Energy represents the ability of an object for doing different actions. Temperature is used to represent the concentration of thermal energy within an object. Current represents how many charged particles carrying charges per unit time. Knowing physical quantities is very important to describe the physical phenomena occurring around us properly. 1.2 Base quantities, their units and symbols. Depending on the dependencies of physical quantities are divided into two groups, base quantities and derived quantities. Base quantities do not depend on any other physical quantities. They are fundamental quantities. There are only 6 base quantities in physics, which are given below: mass, length, time, temperature, current, and amount of material. SI unit of mass is kilogram, which is written kg in short. SI unit of length is meter, written in lowercase m in short. SI unit of time is second, and S is the shorter representation of second. SI unit of temperature is Kelvin, which is written as uppercase K. SI unit of current is ampere, written as uppercase A. SI unit of amount of material is mole, and written as mol, mole. As standard symbol, small m used for mass, small l is used for length, small t is used for time, theta is used for temperature, uppercase I is used for current, and small n is used for amount of material. 1.3 What are derived quantities? Derived quantities depend on the base quantities according to their definitions. For example, speed is a derived quantity which depends on length and time, since its definition is length traveled per unit time. So speed has a unit meter per second, or m into s to the power minus 1. Area is a derived quantity which is defined by the product of two linear dimensions. Area of rectangle is length times width, and area of right angle triangle is half into base into height. So unit of area is meter square. Common derived quantities are area, volume, speed, velocity, acceleration, momentum, force, moment, energy, density, light intensity, charge, voltage, power, etc. There are no hard and fast rule that a quantity has to be written with some specific symbol. This is completely customary. You can choose any symbol for any quantity, but it is better to use the standard symbols. For example, symbol F, M, and A are used to represent force, mass, and acceleration respectively. According to the Newton's second law, the relationship between these three quantities are written as follows: F equals to m into A. But there are many forces usually act on an object simultaneously. If there are 3 frictional forces acting on the same object, they can be symbolized by F1, F2, F3, or by P, Q, and R. It is better if a symbol is written by the first letter of the physical quantity. Physical quantities have their own specific units. So a unit represents a specific physical quantity. The numeric value used with the unit represents the magnitude or strength of the physical quantity. For example, a length of 4 meter represents a distance which is double of the length of 2 meter. For the ease of identification and generalization, physical quantities are written by means of specific symbols.